Bonjour, good morning. Um, there's a new lecture series on plane geometry 2, specifically circle theorem. So we are done with statistics. We'll come back to it again and talk about mean deviation, standard deviation, variance, and cumulative frequency behavior, also called OGAI. Yeah, so for this lesson and the subsequent ones, we'll be talking about circle theory. Now, before we begin, I'll be using the circle language, so we have to understand a few terminologies associated to that. So, um, let's begin. What it's a circle? We are all familiar with it when we talk about what a circle is, but how do we define that? So, let's make some notes. So, definition of a circle. So, typically, when we talk about a circle, we all know that this is it. That's right. But how do we define it mathematically? So, let's try. A circle is defined as a circle is defined as define the locus of a point, equidistant. The locus of a point, equidistant. Remember, this is a very examinable area. Whether you like it or yes, you will get a question, a full question on this in section B, and a couple of questions on this from section A. If you miss the classes, you're on your own. You may be seeing that, oh, it's recorded, it's going to be uploaded on our channel. Ask yourself, how many of the videos I've uploaded have you watched? And the more it accumulates, the more it becomes overwhelming. So you don't have to miss it. You have to be in class at all times. A circle is defined as the locus of a point. Equidistant. So what does this word mean? So locus, equidistant. Yeah, so let's explain that. So let's talk about locus. The idea of locus is derived from the topic construction, geometric construction. Did you do that in school, Victoria? Did you do that in school? Locus. Sorry, geometric construction. Bediako. Do you do something like that in school? What are some words you remember under construction?
Construction.
Yeah, did you do that in school?
So no. Construction. No, that was advice teachers we didn't do.
You never did geometric construction in school.
So no, the only construction I remember was in DHS.
Uh-huh. Is it not the same thing?
Yes, sir.
So what other construction again do you think I'm talking about? Anyway, yeah, so that's the same construction.
Okay, sir.
So what do you remember about construction, Sandra? What reminds you about construction? Anyone, let me throw into anyone. Some of you just don't like being honest. Why do you make studying so hard for yourself? What do you remember about construction? You can speak it in any language. Get a translator. Prince. Some of you are just not. So you are you trying to say you never did construction in school? What are some of the stuff you did back then? What do you remember? You have limited time. Grace. Grace. Hmm?
Remember,
Yeah. What would
Shit. I'm not asking you to
Yes.
go and look for big, big words. You do construction. What exactly do you remember about it? Hmm?
Sir,
Yes.
it's about drawing lines and constructing angles.
Yeah, you were drawing lines, making angles. Were you not drawing circles? Don't you remember having triangles and you end up drawing circles around it or sometimes circles inside?
yes, sir.
You never did stuff like that. And when it touches all edges, you are happy. And we're doing stuff like this, right? Drawing lines, arcs, drawing straight lines. Can you see my screen?
Yes, sir.
What? Okay, yeah, so that is it. Yeah, that's the kind of construction I'm talking about. There is nothing else. So what then is a locus? So locus is defined as the part. It is the part. It is the part. Yeah, let me remind you, it's we are doing theory all over. Because if I start circle theorem is a very brief topic, but if I start the theorems, I'll be using the language and you may not understand. So it's better you get the language now than before I get there and I'll be using the words like circumference and stuff like that, and you'll be wondering, say, what exactly are you talking about? So it's important not to miss this. So it is a path, a point, traces obeying certain rules. Let's use a semicolon.
Yes, and then you put things up. Patience.
Hannah, read what you see.
Yes.
Instead, it's the path and point traces. Obeying certain rules.
That's right. So when we talk about path, I guys done writing. The prefix should regulate this for me. I want to ensure everyone is following.
Yeah.
I have a call, guys. Hold on. I think it's from my bank. Let me just pause this briefly. Just a moment. Pause. In geometric construction, you see that there are a lot of locals we make or create. You see a triangle with a circle inside. You see that triangle with a circle outside. You see a line that is going vertically. Okay. And there are other locals you can think about. Yeah. The lines, the circle is what we call locus, meaning the point alternate or revolve around one particular point. Okay. Sometimes they go in a circular path. Yeah, so it depends on the rules. So there are rules, there are rules. That's what generates the locus. So you get a circle outside, you get a circle inside. Yeah. So in geometric construction, normally listen about the question, look at the properties associated to that, and by the time you realize you have a circumcircle or an incircle, okay, or you have a line, a straight line. Guys, are you following? So I'm going to tell you one rule. One rule is so that's what it defines a circle. So when we talk about a path, you see, path is like can someone give me a better word for path? Path, like a road. Okay. Yeah, so Now, this is what happens. So whenever you have, pay attention. So whenever you have a fixed point, and if you're smart, you get to know what I'm talking about. You have a fixed point, okay? Let me see what I can do. And yeah, so this is our fixed point. Then you have other points. And these other points tend to have like a particular property. Do you know the property? You have a fixed point, then you have other points, and these other points, and do you know their property? The property is like the distances from those points, Okay, the distances from those points to the fixed point, they are the same. If you use a ruler to measure from here to here, you have, let's say, 5 centimeters. If you use a ruler to measure any of the other points to the fixed one, 5 centimeters. This one too, if you use a ruler, you measure 5 centimeters whenever you have a fixed point. And you have other point, and the other points are such that the distances from those points to the fixed points are the same, are of the same magnitude, the same length. Okay. Then the locus of those points, again, the road those points tend to trace is a circle. The path they follow is a circular path. Don't mind me, the line should fall on the point, but in fact, I'm using a freehand, so. Is it bringing a picture to your mind? And it's true. Whenever you have a circle and you have a fix, so the fixed point is normally what? Who is going to be smart here? The fixed point is always what? See it. Someone is there. Oh, they went off. The fixed point is what? Ajua, does it bring something to mind? Ajua, today we don't have enough time because of the devotion, but let's do something meaningful. The fixed point is what? Right now. Ajua, you can't hear me.
No, you are breaking. I can't see what you are saying.
It's your connection. It's your connection. Madam, you have to fix that.
So I'm done.
Yeah. The fixed point is what? But wait, did you understand everything I said earlier? Did you get what I said earlier? I said to be able to get a locus, to be able to identify a path a point will trace, there must be certain rules, right? And I'm saying that as when you have a fixed point and you have other points, and the other points are such that the distances from those other points to the fixed point are the same, are the same, are the same. Then the path those points trace is what? A circle. The path those points follow is what? A circle. Okay. And I'm asking, and it's very true. It's very true. But to studying this picture, looking at the circle as being the locus, the center, oh my God, the fixed point is a center. I've answered myself. The fixed point is a center, right? The center of a circle is what generates a circle of even part. All right. Yeah, the fixed point is a center. It's always a center. Okay. Um, do you all have a compass? Do you all have a compass? Oh, I'm not sharing my screen. You can't even see my screen.
Then we can see your screen.
No, you can see my face. I'm not sure you can see the board. Or you can see the board.
And you can see everything.
Okay. Yeah. But do you guys have a compass? How many of you have a compass? Like, I want you to draw a circle. How many of you have a compass?
Very few.
Hey,
Okay, guys, that's fine. That's fine. Pay attention. If you know this, be honest with me. Pay attention. Whenever you draw a circle, okay, whenever you draw a circle, you're using a compass. Those talking. When you have a circle and you are using a compass, madam,
No.
yeah, I'm thinking of something. Yeah.
Okay.
Are you sure, guys, you can see my screen?
Yes, sir.
Yes.
Uh-huh. Okay. Yeah, so guys, if you don't relate, let me know. When you draw a circle with your with your compass. Okay, when you draw a circle with your compass, you see the compass will be hooked at one place, and that's what you use to draw the circles. At the end of the day, at the end of the day, it makes a dot, a hole there, right? It makes a hole. Then you've produced your circle. Um, the distance from the if you think of any line on the circle, hmm? If you think of any line, any point on the line, like on the line, do you know that the distance from any point on the line will come to use if you use a ruler, if you measure from here to here, the value you get is the same as measuring from any point on the circle. Do you know that? Do you know that? You know, maybe margin and alcohol. Do you know that if you measure from the fixed point, okay, to the circle, okay, or in other words, if you think of any point on the circle, the path, okay, to that is the same. The distances are the same. Do you know that? Hmm?
Yeah.
They are the same. Who can't relate? Who can't relate? Be honest with me. Don't make the teaching so hard. I just want a yes and a no. Say, I do not understand. I understand. Don't shut up and sit there and make me talk and talk and talk. I don't like that. Yes, who can't relate? And do you have a compass in a room?
Yeah. Yeah.
So who can't relate? Then we can look at that person. I mean, we can solve this. But Ajwa, this thing I'm talking about, are you able to picture it well, or you also have issues, I mean, creating a picture of that?
No.
Are you okay with that?
Yes.
Uh-huh. Um, who can't relate? The prefer you can look at them. If someone raise a hand, let me know. And then let's get a compass from someone and I'll show you something. Right, yeah. So did you get some people raising their hands? Can we attend to them? Can we give them why do I even mix words? The compass. Did you get some people raising their hands to the prefect?
Oh.
No, it's fine. Yeah. But when you go and draw a circle, use the what's the name? Compass. Use a compass. If you use a compass to produce a circle, the compass will definitely make a hole, okay, in a circle. Where it makes a hole, you can make a dot over there. Okay, you can make a dot over there. A dot over there. Then now the circle you've drawn, get a red pen or whatever and make some dots on a circle. I just hope you go and try it. I know the smart ones or the serious ones will go and try that. Just make any dot on a circle. Make about 2, 3 dots and take your ruler. Measure from that dot to where the hole is. Measure all the dots you made on a circle to where the hole is and see. You see that the distances are the same, right? So it confirms that when you have several points and you have a fixed one, so the fixed point is where your hole is. When you have several points, you have a fixed point. The distance and the distance from those several points to the fixed points are the same. Then the locus is what? The path. Did I say the locus is the path? The locus is a circle. Okay? Yeah. And I define a circle as the locus of a point, equidistance from a fixed point. And it's true. So the word equidistance is a amalgamation of two words, equal distance. Okay, equal distance. So when you have a point that are of equal distance to a particular fixed point, some are kind of that. When you have a point that or several points that are of equal distance to a particular fixed point, that's if you measure to a fixed point, they are the same, then it's a circle. The locus is a circle. Do we understand? Do we understand?
Yes, sir.
So I can move on.
Yes, sir.
Okay, so I just wanted you to know what a circle is, and as a senior high school student, if someone asks you what is a circle, at least you will be able to say something. So at this point, I want us to now talk about certain terminologies I'll be using in the properties. Okay, so we're going to take them one after the other. I'll discuss what it is. Okay, then we can now start with the theorems. The theorems are just we talk about them and yeah. So definition of some terminologies. Or you can simply say, in fact, they are the part of a circle. So some parts of a circle define. Let me just come down like that. Are you ready? Now, if you understand this properly, mensuration, I may not talk about this again. Guys, can we begin? But I just want you to know what we'll be doing. So let me write them. Number one, I want us to discuss what a circumference is. Circumference. Two, arc, three. Yeah, when we talk about this, let's talk about what a chord is. I think after that, let's talk about diameter. We talk about radius. Is radius okay? What's that? Radius. Substance. No, I don't think we need segment. Segment. We need, I'm kind of lost. Well, if I see it's not important, we'll not use it. Yeah, that's all. Well, words like semicircle, quadrant, we'll use them when we are talking about mensuration. So I have 5 minutes. Can we move on? Can we move on, guys?
Yes, sir.
Okay. Yeah, so we are defining circumferences now. It is a circular part of a circle. Okay. Now, I would like to illustrate it with a circle. Pay attention. Yeah, I want to illustrate this with a circle. So, good. We got a perfect one. Yeah. So when we talk about circumference, we are talking about the black line. Okay. So let's say you start from a point like this. Okay. A point like we are outside though. Then circumference is from here. Okay. All the way and back to the line. That's circumference for you. In science, we were talking about the shell, right? The black line, you get it. And you see that when I said when you start from this point, I didn't say when you start from here then end somewhere. No, no, no. I said when you take a complete revolution, that's what the circumference. We can draw that circle. So assuming there's another circle, okay? The circumference, let's think of a point here. The circumference is from that point all the way up and back to the point again. So guys, if you're following the lesson closely, I never said when you take a point, let's see, no. It looks like I'm placing the point at one particular place. Let's say I never say if you think of a point here, the circumference from here, then maybe here. No, no, no. When you start, you make a complete revolution, right? That's the whole thing, circumference. Okay. Another name given to the circumference of a circle is what? Perimeter of a circle. So in mensuration, the topic mensuration, if they ask you to find the perimeter of a circle, it's the same as what? Circumference, perimeter. Listen to me more than what I'm writing it, because you may not see the handwriting. Yeah, so perimeter. Another name given to circumference of circles or perimeter of a circle. Okay. Because perimeter means sum of all the sides, sum of all the sides. And you can see that when it's about circle, we take a complete revolution. Start from here, you take a whole turn. So circumference of a circle is the same as the perimeter of a circle. Yeah, in mensuration, we'll be asking you to find the perimeter of a circle. Yeah. Or circumference of a circle. You'll be asked to measure. You'll be asked to give a numerical value for its measurement. Well, we'll talk about that. But in circle theory, you just need to know what circumference of a circle is, because in the theorems, you will be using the words. Okay? The angle a chord subtends at the center is twice angle makes at the circumference. What's circumference? What's that? Yeah, so you know. Yeah. Victoria, do you understand what a circumference is? No, Victoria.
Adam. Under of the family. Yes.
What is the problem? What is the problem? Can you hear me?
Yes, sir.
All right. Yeah. Do we get it? Prince, Anthony, Grace, Bidia, Komboima, Hannah, Sandra, Rahel, Ajua, Victoria, Patience, Jessica, Frank, Michael, Evelyn. Do you understand?
Yes, sir.
All right. Next meeting we will talk about arc, okay? Chord, diameter, and rest. Do you have any question?
No, sir.
All right. So this brings us to the end of the lesson. See you in another lecture. Hold on, let me end the recording, then we can discuss other matters.